Hello students, we have almost come to the end of the chapter phenol. Few more name reactions to be learned. The first name reaction is coal-base reaction. These are also electrophilic substitution reaction, but they don't fall under the usual categories which we have discussed so far. Now, when you treat phenol with alkali such as sodium hydroxide, the reactivity of phenol increases, so it becomes sodium phenoxide. When you treat this with carbon dioxide, which is a neutral electrophile, carbon dioxide structure is this, and you can see it is carbon is attached to two oxygen and the oxygen is strongly pulling electron from carbon. As a result, carbon develops a positive charge, so it can behave as an electrophile. So because of this, as such carbon doesn't carry any positive charge, it is a neutral molecule. So when phenoxide ion is treated with carbon dioxide followed by hydrolysis with acid, then it forms salicylic acid, that is 2-hydroxybenzoic acid. That means in the ortho position we get introduced a carboxylic acid group. Okay. So this reaction particularly helps you in preparing a very important painkiller that is called aspirin. Aspirin can be prepared by salicylic acid by esterification reaction. Now we know that normally for esterification reaction we need alcohol and acid, and by loss of water it forms ester. But here the salicylic acid, the OH group will serve as the source of alcohol, and the reaction will not take place with acid, but it will take place with acid anhydride, that is acetic anhydride. Now what is anhydride? You see, normally we write acids to be RCOOH. Okay, if I have two molecules of RCOOH and if we remove a molecule of water from here, then whatever we are left with, that is called carboxylic acid, acid anhydride. Okay, and it's written like this. It can be written like this. If your R group is CH3, then we call them acetic anhydride. In some books you may find it written like this. In some books you may find it's written like this, RCO twice O. This way also it's written. Somewhere you may find it's written like this, AC2O, where AC group stands for CH3CO group, acetyl group. AC2O also stands for acetic anhydride. So when salicylic acid, that is 2-hydroxybenzoic acid, treated with acetic anhydride followed by hydrolysis, it forms a very important class of medicine, that is aspirin. Okay, so this is an important reaction, please try to remember. Now what is the specialty of aspirin? You see, aspirin has an anti-blood clotting ability. Now those people who are having high blood pressure, they often have the tendency of heart attack because of the clotting of the blood. So those people, those who are suffering from high blood pressure, if they are having a kind of pain, headache or whatever, instead of taking any other medicine, if they take aspirin, then the blood will remain in the liquid form. It will prevent the blood from clotting or thickening. Okay, blood thinning drug. Very important. So that's how we prepare aspirin, and the starting material can be obtained by coal-base reaction. The next reaction is Rhema Taemin reaction, another very important name reaction. It is also an electrophilic substitution reaction, but here when phenol in the alkaline medium, same with sodium phenoxide, is treated with chloroform. You can see here CHCl3. Then instead of getting a COOH group here, we get CHO group here. So it is ortho-hydroxybenzaldehyde or 2-hydroxybenzaldehyde. This is also a very important reaction and very often asked. So that's all about the name reactions. The next set of reaction of phenol is reduction. Now remember, in phenol, because of extensive resonance, resonance. As you know, this lone pairs on oxygen, they get involved in resonance, because of which the CO, this particular bond becomes partially double. Right here, this becomes double, because of which the bond enthalpy of this bond is very, very high. So we will not find any reaction where we have done reactions involving cleavage of COH bond, whereas we have done so many reactions under this heading in alcohol chapter. But this is the only reaction which we will be doing is reaction with zinc. When phenol react with zinc, it gets converted to benzene. So it is important in terms of conversion also. So phenol, when treated with zinc, it gets converted to benzene. Remember, it's commercial zinc, not the pure zinc, and zinc oxide formed as a byproduct. So since removal of oxygen takes place here, we call the reaction to be reduction reaction. Next is oxidation. Phenol, even if you leave it in the atmosphere, it turns brown. You know, phenol as such is transparent crystalline structure, but if you leave it in the air, it will turn brown because of oxidation. But however, here we are using a strong oxidizing agent, chromic acid. In your book, you may find it's written sodium dichromate and sulfuric acid. It gives you the same thing. And when phenol gets oxidized, it forms a diketone called benzoquinone. You can see here the aromaticity is lost. There will be two oxygens getting attached in the para position with respect to each other, and the triple bond gets converted to double bond and attain these parallel positions in the benzene ring. So try to remember this reaction as well. In fact, all the reactions are to be remembered only. Next is, if you are given phenol in the lab, then how would you know that this is phenol? Alright. Now this is a very simple test which we do in the lab also. When we will be doing practical, you will be performing this experiment. To phenol, we add ferric chloride. Ferric chloride itself is pale yellow in color, but when it is a very fast reaction, it immediately changes its color and forms a complex. Okay, FeOC6H5 times 3 minus. Now how we get this structure? As you can see here, from phenol, if this hydrogen is removed, then we will be left with phenoxide ion, PHO minus, or in other words, C6H5O minus. Now in ferric chloride, the oxidation number of iron is +3. Now here what happened? We have taken 6 phenoxide ion and 1 iron. So 6 phenoxide will have 6 negative charges, -6, and 1 iron will have +3 charges. So overall charge on the complex is 3 minus. Okay. Now depending on the phenol, like we may have phenol, we may have paranitrophenol, we may have chlorophenol, we may have naphthol. So many types of phenols are there. Now this complex will have different colors. It may be red, it may be green, it may be blue as well. Okay. So with this we come to the end of the reactions of phenol.